This video is going to have a look at the greenhouse gas effect and how that impacts on our climate. So we tend to refer to that impact as climate change. It's sometimes called global warming, and while it's true that it is raising global temperatures, it doesn't necessarily mean that everywhere is getting hotter. In fact, some people like Britain in the winter will get colder. So we tend not to use the term global warming because it's a bit misleading, and we tend to refer to it as climate change. But you need to understand the mechanism by which this works, but you also need to be able to describe graphs, compare graphs, and analyze data. So we're going to have a look at that. So this is the first diagram, and this just shows us how the greenhouse effect actually works. And you'll probably be quite familiar with this. So around the Earth, there is this layer called an atmosphere, and it's kind of like a jacket. So it's lots of different gases, mostly nitrogen and oxygen, but a little bit, normally it's actually less than 1%, it's made up of other gases like methane, water, carbon dioxide, which are all greenhouse gases. Now, because the percentage of these gases is so low, when we talk about very, very slight increases in the amount of carbon dioxide, for example, put into the atmosphere, that makes a big impact. So to give you an example, if we said we've got 0.1% more oxygen in the atmosphere than we did last year, well, actually, that's really not much, because 0.1 is a very small percentage of 21%, which is the percentage of oxygen in the atmosphere. If we said 0.1% extra carbon dioxide in the atmosphere, well, that's a huge chunk, because that's nearly double the amount of carbon dioxide. So what does this do? So as the energy comes in from the sun, some of it bounces back out into space. Other bits come in and they stay within our atmosphere and they heat up the surface. Mostly they heat up our oceans. Now, this process of being trapped in our atmosphere is actually caused by the gas particles absorbing that heat energy or that energy, and it causes the bonds to vibrate. Now, you don't need to know the specifics of that, but it's quite a lot of the time we talk about it being trapped and reflected. It's actually absorbed by the atmosphere. So what that does is it makes our atmosphere get warmer, and then that heat gets transferred onto the surface and more so into the oceans. If we have a look at a planet like Venus, Venus is actually the hottest planet in our solar system, but it's not actually the closest to the sun, because Mercury is closer. Now, the reason Venus is so hot is because it's got a very, very carbon dioxide rich atmosphere, which traps a lot of the heat energy. And that's because of the number of volcanoes on it. So the volcanoes release carbon dioxide that traps the heat energy from the sun, and it warms up the surface of Venus. So Venus has got a runaway greenhouse gas effect, which is kind of sometimes seen as a future for our planet. So let's have a look at some of the data. So we kind of ignore nitrous oxide. It is a greenhouse gas, it's just not in huge proportions. But if you have a look at the other two lines, and you could also look at nitrous oxide, carbon dioxide and methane and water vapour are the three biggest contributors to greenhouse gas effect. Now, we don't have water here because it's not changing that much, but carbon dioxide is increasing very rapidly in the last sort of 100, 200 years since the Industrial Revolution, and it's the same with methane. If we have a look at the global temperatures, we have also got this positive correlation. So gases, these greenhouse gases have increased, and so have, funnily enough, in the last 200 years, the global temperature. Now, quite a lot of people tend to argue, and this is one of the arguments against global warming and climate change, that because this fluctuates, so you see it sort of goes up and down, because it fluctuates so much, it can't just be the greenhouse gases that are causing this change. Well, yes, that is potentially true. There might be other factors at play, but we can't ignore that our global temperature is actually going up faster than it ever has, and that's causing other issues. So whilst it does fluctuate, so there might be other factors, there is going to be some correlation, there's going to be some cause and effect. Another bit that people tend to argue is this. So this is the temperature of the Earth in our entire history, right? We're looking at very hot periods and very cold periods, and we're currently down here. Now, the last time we had a mass extinction was here, and we've got this rapid change in temperature. we're actually seeing a very, very rapid change in temperature here too, which is probably one of the reasons why we're getting things like mass extinctions at the moment. So yes, the planet has gone through these long periods of heat waves and ice ages, and we're currently actually a little bit colder than average. But it isn't so much the actual temperature of the planet that's concerning, it's the rate at which it's increasing that we need to be concerned about.